So students, today we will demonstrate the setup that we are using for Zeeman Effect experiment. Okay. So broadly we have a mercury lamp. Okay. Here. So this has mercury vapors that we can pass an electric current to basically ionize the mercury, which then gets excited and emits light. Okay. So there are a few current sources here. This current source is for an electromagnet. This is the electromagnet which is surrounding the mercury discharge tube. So when we apply a magnetic field, it will basically split the lines, the initial lines of the mercury. Okay, so that is what Zeeman effect is. Okay, so now it does not have any magnetic field, so it only is giving the normal emission. From excited atoms, the excited atoms going back to the ground state, it emits lights. Okay. Then this is the electromagnet, and its power supply is this one. Then you also have a gauge meter. So as you can see, this one. So this we can use. It has a probe, as you might have already used in some of the earlier experiments. So this we will basically insert here between the two poles. These are the two poles here. So and measure at what current we are getting at what magnetic fields. Okay. Then we have this mercury discharge tube which emits light, but we want interference. So that means we want to select a monochromatic light. So if you can see, there is a filter here which appears green because it's a band pass filter, so it allows only a small band of wavelengths around 546 nanometers, that is green light, to pass through it. Okay, so essentially it is like a monochromator, so it is creating a monochromatic light from the polychromatic light that the mercury here is emitting. Okay. Next, in the setup, this is an optical bench that you can see partly on your screen. This has a scale, and on top of which we can mount different optical instruments. Okay. Next, there is a polarizer. So the polarizer also has a focusing lens on this side, and there is a Polaroid here on this side. Okay. So what is the role of polarizer? Again, you will once you read the manual, you will be able to understand. Basically, even after we are having this monochromatic light, once we get through the splitting, we want to select particular transitions. So that is why polarizer is here. How it can do it, again, go and read the manual to understand it. Okay. So after this polarizer arrangement, you will probably not be able to see very clearly, but we have the interferometer, the Fabry-Perot interferometer. This thing is called the Fabry-Perot interferometer. Okay. This is the polarizer, this is the Fabry-Perot interferometer. So what it does, basically, it has two closely spaced, partially reflecting glass plates. Okay. This is one glass plate, this is another glass plate. As you can see, there are a few knobs attached to this other glass plate. Okay. Also this knob and these two other knobs are there. So this basically does what? This knob changes the distance very slowly. It changes the distance between the two glass plates. These two knobs slowly changes the angle of tilt, okay, of one of the glass plate. All right. Also, we want the distance between the glass plate to be to around the preset value. So there is a basically a rod with 4 mm thickness which we initially insert between the two glass plates and make sure that we can just insert it. There is not much of a gap left. Okay. So that way we start with around 4 mm distance between the two glass plates. Then we do minute adjustments using this screw till we get a proper fringe pattern. Okay. All right. Now this is the Fabry-Perot interferometer, which gives you the interference rings. Okay. After that, here if you put your eye and see, you will be able to see fringes. Okay. But you want the fringes, but because the fringes are very closely spaced, you want them want to magnify it. So what do? We use a telescope here, which then focuses those fringes on a CCD camera. This is a CCD camera. This is a telescope. This is a CCD camera. Okay. So this CCD camera then converts this optical information into electronic information, and then feeds into this screen monitor. Okay. Television monitor. Also, here you cannot see, but this is also a power source. Okay. You cannot see it because the knobs are on the other side. So this power source supplies powers to all the other equipment other than the electromagnet. Okay, because electromagnet requires higher current, so it is a separate power supply. So this supplies power to all the LED screen, the CCD camera, and everything else. Okay. So also you have a leveler. So basically we use this rod and we keep everything at one single level. Instead of measuring and trying to optimize it, we just use this rod which has a fixed height. Okay. So this basically describes all the different components that you have in this experiment. Okay. Next up, we will explain to you how you do this experiment. Also, you can see this is the telescope. This telescope, this is the CCD camera. CCD camera, the telescope, and all these other your optical setups are mounted on stands. These are called stands. Okay, this is the optical bench. These are called stands, and they have micrometer screws. You can basically, this is like a screw gauge. Okay, you can measure small distances using this screw gauge that is attached to it. Okay, micrometer screws. So small movement of the CCD camera to basically focus once on one fringe, then to move to the next fringe, then to the next fringe. So all those distances you can measure using this screw. Okay, this basically screw gauge. So you have a magnifying lens right on top of it. There is a small LED here because you will be doing the experiment in the dark, so you can turn on this LED and see the readings. Okay, so that broadly describes the entire instrument.